Okay, so I mentioned a while ago that there were two types of logs, so we're going to look at the second type now. So the difference with this other type is the fact that you're going to have logs on both sides. A while ago, the one side of your equation was always just a number. And actually, these end up being a little bit less work usually. If you have the same base, like this is, say, log base 5, this is log base 5, then the only thing you have to do is just figure out, well, what's going to make these arguments be the same. So when it comes to working these, all that you have to do is just pull out the arguments and set those equal to each other, because these are both natural logs, so they're both base e's. I just need to figure out what makes these two arguments be the same. So that's why we can just pull the arguments out, like I said, and just set these equal to each other. So all you have to do here is just solve this equation. So I'm going to subtract my x, so that'll leave me with a 3x, add my 7, so I get 3x is equal to 18, divide by 3, x equals 6. You still have to check these. You have to check all log equations. So if I were to substitute in the 6, 4 times 6 is 24 minus 7, so that will give you something positive. And 6 plus 11, of course, gives you something that's positive. So that one does check. So when you've got logs on both sides, remember, you just need to pull out your arguments and set those equal to each other. Okay, next one. Okay, so I have switched this one over to using LOG, but it's still exactly the same process. Of course, log base 6, so I just need to find out what makes these equal. So take your 3x minus 10 equal to 14 minus 5x. Okay, so if I solve this, I'm going to start by adding the 5x. So the 3x plus the 5x will give me 8x, which means that I'll need to add the 10. So that's going to give me 24. Divide by 8, I get x equal 3. Okay, so I need to check it. But what's going to happen here is when I substitute 3 into this argument, of course 3 times 3 is 9, 9 minus 10 is negative. So remember, your argument cannot be negative. Now this is the only possible answer that I had, and of course it doesn't check, so your answer here would be no solution. Okay, looking at one more of this type. So again, I've got logs on both sides, but the difference with this one is your left-hand side is not just a single log. So like we saw earlier, we do need to have this where it's just a log equal a log. So I need to put these two together. So since they're separated with addition, that means that I can put them back together and multiply. So x plus 3 times x minus 2. Okay, so now that I have just a log equal a log, now I can pull down and just set my arguments equal to each other. You're going to want to FOIL this, so let's just go ahead and do that as we bring it down. So I'll have x squared minus 2x plus 3x minus 6 equal to 14. Okay, you will want to combine negative 2x plus 3, so that gives us a positive 1x, but you will want to subtract the 14 because you do want this to be equal to 0. So if I subtract my 14, then I'll get negative 20, and this will factor for us. So we'll have x plus 5 times x minus 4. So x is equal to negative 5, and x is equal to positive 4. Okay, so if I check, negative 5 plus 3 is negative 2. So it doesn't even matter if it checks here. If it doesn't check in the first one, then you have to discard it. Okay, positive 4, so 4 plus 3 is 7, so we're good there. And 4 minus 2 is positive 2, so positive 4 is your answer.